Hi, my name is Vanessa de la Torre, and today I'm going to be presenting my final delivery for this semester's key activity for energy and transformation. Okay, so out of the 5 launches I did with my catapult, I chose number 1 and 3. Launch number 3 was the one that had a greater height. This is because of its angle. Launch number 3 had a launching angle of 76.88 degrees. This made the projectile go higher, reaching a 0.630 meter reach. That's why it was higher, because of the angle. Out of these 2 launches, the one that had a longest reach was launch number 1. This has to do with the explanation I just gave. It traveled further than the third launch because of its angle. This launch had a launching angle of 45 degrees. This let the projectile have more time to impulse and travel further away. As for the third one, it didn't have as much space as the first one because it just traveled like this, and this one traveled like this. That's why the first one had a longest reach. Okay, so now I'm going to present my procedure to get the direction and the velocity. First, I got my maximum height and maximum range from my table of information. I got my time also, but this time was recorded in slow motion, so I need to divide it by 9 to get my normal time. After that, I looked for my velocity in y. I did it with the third formula. I just plugged in all of my data into the formula and got this answer. That is my velocity in y. Then I looked for my velocity next with this formula, which is velocity, it's equal to distance between time. I just plugged in my data and got the answer. The next thing I needed to do was get my velocity. This can be done by using Pythagoras. So I just plugged in y and x, I squared it, and then I got the root, and that is my velocity, which is 4.567 meters per second. The last thing I need to do is get the angle, which can be done by using the arctan formula. I just plugged in again all my information and got an answer, which is my angle, and that is 61.78 degrees. For my next launch, I did exactly the same. Get maximum height and range and the times, find my velocity in y using the third formula, find my velocity in x using the distance between time formula. I plugged that information into Pythagoras and got my velocity. To finish, I just used my arctan formula, plugged it, my information, and got my angle of 63.95. Okay, so there are obviously some differences between mathematical and experimental calculations that you use with Tracker. Some of these differences can be that simply just by your reasoning and your thoughts and your procedure you can be correct, but also using Tracker can be correct. It will give you quick answers and no need to do all this procedure, but if you want to make sure that you're correct and understand all the procedure, then you should make it by your own. Okay, so from this experiment, I can say I learned a lot. First, I learned some types of catapults that have existed or that exist right now. I also learned how to build a catapult, how to use some tools. I also learned how to use this application that is Tracker to get different type of launches or projectile motions like this one. So that was fun. Okay, so I think this knowledge has more applications than just a project. Obviously catapults in real life, but also getting to know the complete procedure of a projectile motion, like is from American football, how they launch a football and you can see all the way it went, and you can track all the stats just by making these procedures. So football or cannons or catapults.